Have you ever just stopped and wondered what's actually happening inside an AI when you give it a command? You know, it feels like magic, but it's really not. Today, we're going to pull back the curtain. We're going to build an AI from the ground up, following the actual blueprint, piece by piece, so you can see exactly how it thinks. So that's the big question, right? How do we go from the words we type to a real, tangible action? What looks like instant understanding is actually a super precise mechanical process. And in this explainer, we're going to walk through that entire blueprint. You'll see exactly how the sausage is made. So let's start at the beginning, with the foundation. All right, so just like any big building project, you've got to start with a solid foundation. For an AI, that foundation is its brain. It's the core engine that does all the heavy lifting, and it's called a large language model, or for short, an LLM. Now, an LLM is called a foundation model for a reason. Just imagine an AI that has basically devoured a huge chunk of the internet. We're talking books, articles, websites, the whole shebang. All that reading gives it this incredibly broad, general understanding of, well, almost everything. And that foundation can then be specialized for all sorts of tasks, from writing software to analyzing medical charts. You know, that term neural network isn't just a fancy tech buzzword. It's actually the perfect analogy. These systems are directly inspired by how our own brains work. They're built from this massive, intricate web of interconnected points or nodes that act like artificial neurons, all working together to find patterns and make sense of information. And here's the wild part. What each one of these individual nodes does is actually super simple. It just does three things. It receives a signal, it processes it with a quick math problem, and then it passes the answer on to the next layer. That's it. But when you get billions of these nodes all doing that simple dance at the same time, that's when they can start to tackle these incredibly complex problems. Okay, so we've got this brain, but there's a problem. It's a numbers brain. It only thinks in math. And we talk in words. So how do you bridge that gap? Well, the AI has to become a professional translator, turning our language into the only one it really gets, numbers. The very first step in that translation process is something called tokenization. It's pretty intuitive, actually. Just like you'd break down a sentence into individual words, the AI chops up text into smaller, more manageable pieces called tokens. Now, a token might be a full word, or part of a word, or even just a comma. So here's how that whole reading process plays out. First, like we said, the text gets tokenized. Then every single one of those tokens gets a unique ID number, kind of like a library card number from the AI's giant vocabulary. And finally, and this is the important part, that simple ID number gets turned into a long list of hundreds of other numbers. This list is called a vector, or an embedding. You can think of this vector as the AI's true mathematical definition of that word. And this is where the real understanding clicks into place. Those vectors act like coordinates, plotting every single word onto this giant, multidimensional map. In this vector space, words like king and queen are basically neighbors. Dog and puppy are right next to each other. This relationship, this physical closeness on the map, is how the AI actually understands context. It's not about definitions, it's about proximity. Okay, so our AI is getting pretty smart. It can think and it can understand our language by turning it into math. But how do we actually tell it what to do? You know, how do we give it instructions that are so clear it gets the job done right every single time? Well, that's where prompt engineering comes in. Probably the easiest way to think about this is with a job analogy. The system prompt, that's the AI's permanent job description. It defines who it is, what its personality is, and the big rules it always has to follow. The user prompt, on the other hand, is the specific to-do list you hand it right now, like, hey, write this email or summarize this report. And a really good job description, a solid system prompt, basically has to answer 4 key questions for the AI. First, the role. Who are you? Second, the tone. How do you sound? Third, the rules. What's your process for getting things done? And finally, and this one's crucial, the limitations. What are the lines you absolutely cannot cross? When you put all those together, you turn a general-purpose AI into a specialized, reliable tool. All right, let's recap. We've built the brain, we've taught it how to speak our language, and we've given it a detailed instruction manual. So now, let's put it all together. Let's see how an AI agent actually takes a task and runs with it, from start to finish. This right here is the AI's core operating system, its thought process. It's a 6-step loop for getting anything done. First, it perceives the situation, gathers the facts. Then it interprets all that data. From there, it makes a plan. Then it acts on that plan, communicates what it did, and this is the most important part, it learns from what happened. And this isn't a one-time thing. It's a continuous cycle designed to make it smarter with every single interaction. So this whole system sounds pretty incredible, right? And honestly, it is. But let's get real for a minute. It is far from perfect. It's really important to understand where the technology is today, its limitations, and how people are working to fix them. The short answer to that? No. Absolutely not. And it's so important that we understand exactly why.
So the big challenges are pretty significant. First up, hallucinations. That's when an AI just confidently makes stuff up that is completely false. Second, reasoning. They can sometimes fall apart when they have to deal with really complex multi-step problems. Third, bias. Now, the AI isn't trying to be biased, it's just a mirror reflecting its training data. So if that data is skewed, its answers will be too. And finally, originality. These models are incredible remix artists, but they can't create a truly new idea from thin air.
But the good news is, people are working on these problems, and fast. Techniques like retrieval augmented generation, or RAG, help with hallucinations by basically forcing the AI to go look up the facts in a trusted database before it's allowed to answer. And human-in-the-loop systems, or HITL, are exactly what they sound like. They put a person in charge of reviewing the AI's most important decisions, acting as that crucial layer of human oversight. So there you have it. That's the blueprint. From the neural brain and the language of vectors, all the way to clear instructions and a cycle of action. You now know the fundamental mechanics of how an AI actually thinks. So the question isn't just how it all works anymore. The real question is, what problems do you think are worth solving with it?